Hello, and welcome to the Inflectra webinar on building a UI test automation framework for a Dynamics 365 AppSource application using our Rapise automation tool and SpiroTest test management system. In today's webinar, we'll first be talking about the challenges with testing a web-based custom add-on for Dynamics 365 for operations. We'll talk about the specific challenges about this custom grid control that we're going to be using and how you can use a framework implementation in our Rapise automation tool to handle it more easily. We'll be talking specifically around how you as a developer can implement an extension so that you can hide the complexities of the implementation of the testing so that a business user who understands Dynamics, for example an accountant, can actually do the testing without understanding the mechanics of how the grid works. Once we've done that, we'll show you how you can use this framework extension to make the testing much easier, how you can create a simple test, how you can use the record and play in visual language to test this custom grid control within this application, and then lastly, we'll show you how you can use SpiroTest, our test management solution, to have enterprise reporting and test management of this automation script.
So first, let's look at what we are going to test today, and later I will explain why we need to test it. So we are looking at Dynamics 365 platform. As you know, for this platform, there is an AppSource marketplace where you can download and install applications to your Dynamics 365 instance. As application under test, I'll be using Insights plugin provided by InsightView. This is a pretty big add-on for Dynamics 365. And what's interesting for us today in this add-on is that it's not built just with controls that Dynamics 365 platform provides. It also has some controls in-house controls developed by InsightView company. So though Rapise has built-in support for Dynamics 365 and some complex controls like grids in Dynamics 365, it doesn't have support for every control that every company can use in an add-on that is published on AppSource marketplace. So why to test this? So you can be, for example, a developer of such an add-on, and you want to check that some critical functionality is working when this application is deployed inside Dynamics 365. Or you can be a customer who is using Dynamics 365 and you just want to check that your combined solution works as you expected. So let's go to Dynamics 365 and navigate to the plugin that we are going to test today. So this plugin, Insights, powered by InsightView, shows information about account. This information is gathered from public sources and is shown for an account in a specific panel. So I am going to the list of accounts here. Then I'm choosing Microsoft. And here to the right, we see shortcut buttons of Insights plugin. And let me click Find Contacts. And here we see on the screen this InsightView panel, this plugin, and it shows us the table of contacts. And this table, this is not control provided by Microsoft. This is something developed by providers of this plugin. So if you will try Rapise or any other tool with this control, it will not be supported. It will be recognized just as a combination of cells or a set of some text labels. So, and what problems do we have if we work with this control at the text level? So let me create a new test in Rapise. And we first try to record some actions against this plugin using default functionality. So let me inside plugin, name the test. I'm choosing web cross-browser support. I'll be using Firefox today. And I'll be using, for the beginning, JavaScript mode. And let's start recording. And I'm clicking in the title column or in the first cell on Chief Executive Officer value here. And Rapise captured my action. Let's click Finish and see what was recorded. So here in the object tree, we have this object captured. And let's look at XPath of this object. So this Dynamics 365 is a multi-frame application. So most of this expression is just passing through all the nested iframes. What is important for us is maybe last several components. So this part. So you can see here that XPath refers to a table with specific ID, and that this XPath contains parts that we clicked in row 1 in column number 3. That's all. So what are problems that may arise from this recording, from this XPath expression? So first, the first drawback is that we don't have actually any information about at which column we actually clicked. So we don't know here that we clicked on the title column. So let's go here. We clicked in the title column and no information about that in XPath. So if this column someday will become it will not be the second column, it will be third or first, for example, we will click on some other value. We will still click in the column number 2. And the same is for row index. We wanted to click on some specific value, and this information is not contained in XPath at all. And we always will be clicking at the first row, even if sorting in this table will be different, and this value maybe will be not the first one, or maybe it will become second or third with any other index. These are drawbacks when we perform recording at the lower level. So we do not recognize this table as a real complex object. And here we can see that this is just a click on a particular cell. So what we can do with this? So we will try to create a support for this grid, and the idea is to tell Rapise how to record actions on this table at a high level. So if we clicked on the table, we will record that we clicked in a particular column or on a particular cell. So this way, actions that we will record, they will be resilient to changes in the application, and they will not be, to some extent, implementation dependent. So let's start implementing our framework. So what I'm going to do is to go to File tab here, right-click Test Node, and choose Create User Library. So let me give it a name. And Rapise created stubs for the library. At the moment, it is empty. We have a template for custom web libraries published on the GitHub. So I'm going to visit the repository with templates. Here is web library template. So I'm going to download this repository to the local computer. And here is the template we are going to use. So I'm going to copy it and paste it to our test. So let's open it in Explorer. And here we will put our template. Okay, it is here, and a few files from this template must be added here. Let's go to our test inside plugin and add all the files. Okay, so we did some templating work and created stubs for the plugin. At the moment, this template does not contain implementation for the grid. To do such implementation, someone who will do this needs to know XPath and JavaScript, so this knowledge is required. However, after we will implement support for the grid, users of this library, they do not need to have such big experience. So they may not know XPath in order to use this control and record and execute tests. So after support for this control is added. Okay, let's see what files are included into the template. First, this is description of the library. Here we see some magic lines that describe that this is a web plugin that should work with Chrome, Internet Explorer, and Firefox. And here we have a function that performs detection whether this plugin should be loaded for a particular application or not. I will skip this for now. We have a file that describes types of objects that we are going to support. So here I have a template for the grid object. Here we have a type for the object, and we have a flavor for this object. This flavor will define how this object will be shown in the object tree. So here to the left, you can see that a cell is shown with icon that this is some generic HTML object. And if we will use grid flavor, here we will see an icon of the grid, and it will help us identify the object easily during testing. And here is the reference to implementation of actions and properties of the object. So this is just an overview, so you have a basic idea of what we are doing. The recorder file, this is a part that is loaded into browser when Rapise performs recording or playback. and there is a function that will receive control when we click somewhere on the page, and this function should implement several things. First, it should detect if we clicked on the grid or not. If we did not click on the grid, then this function should pass control to detectors of other controls. And if this is a grid, this function should recognize what we did with the grid. Either we clicked on a cell or sorted a column or something like that. And with this information, this function should help Rapise to record the action. Also, here is the main file we'll be using today. This is implementation of actions and properties for the grid. So far, this is just a stub without particular code that we want to implement. So let's start to implement our library. So first, when we click somewhere in the grid, we want to detect that we clicked on the grid. I'm scrolling down, and here we have a place where Rapise examines where user clicked. For example, when we click somewhere in the grid, then definitely some parent node of the node where we clicked should be the root of the table, and it can be identified using different ways. So actually, let's look at our table, at our grid in the SPY. So I am launching SPY. Rapise has a browser-independent SPY built in. The SPY can connect to any browser and show the DOM tree. And it also supports tracking mode. So what I'm going to do now is to enter tracking mode and move my mouse over the value that we just clicked. And we will look at the DOM tree. Okay, here we see that this is our cell where we clicked, and here is the root of the cell. This is a table. So, and we see here in the property grid to the right that this table has attribute role, and the value of this attribute is grid. So we can close the SPY, return to Rapise, and here instead of attribute name, I type role, and attribute value that we want to find in the role attribute will be grid. Okay, so what's wrong here? Oh, there is a typo. Okay. Let's start recording again. So I start recording. I click on a cell, and what we see here, okay, something must be moved around here. Okay, the row and the grid. Let's check. Okay, we already performed recording, and our library was not detected. So we will set detect web libraries to true to make it again. Start recording. Click. Okay, and now you can see that Rapise recognized that we clicked on the grid, So far, it does not know on which cell we really clicked, but Rapise already knows that this is a grid. The name of this grid is grid, which is a default name, not very good, and we will try to fix it. I double click it here and you can see that the type of this object is the type that we just added without template. So far I will press cancel and let's see how to derive the name of this object from its DOM tree. So here I am scrolling down, we have a get name function called that obtains the name of the object. It is defined here. It derives the name of the object from some attribute. And I remember that there was attribute ID that contains some meaningful name for this table. So I'm typing ID here and let's record again. Click. Okay, here we now see that we clicked on the people table grid. So now I can press finish. And this control was added to my test. So in the object tree, you can see here that this is a grid and it has a meaningful name. We did not record on which cell we clicked and we will implement this later. And if we will expand this object in the object tree, there is an interface that we can implement for this type of control. Properties with blue icon and actions with pink icon. So let's start from implementing some properties. I'm going to the main file that defines the custom control. And here we have entry point for column count. Let's go to scroll down to this function here. Here it is, get column count. And what we see here is that Rapise performs a query of some express that will return an integer value, which will be the count of the columns. So here we just need to enter a path to header cell. Sometimes tables are really tables, like in this case. So we have table tag, and inside we have table row and table header cells. But sometimes tables can be more complex. They can be built with just div controls, and XPath you enter here may be different for different tables. So let's look at our table in more details to find out how to discover the number of columns and how to get the name of the column. This is the next function action we are going to implement. Again, I'm going to launch Spy. And we will try some expressions to discover how to refer to columns and to cells given the root of the table. So let's cancel. Spy again. When we know the DOM structure, we can use relative expressions to. So this is the effect of the demo. I have actually the screenshot of the DOM tree just in case. So here we can see that here is the table, and the table contains head text, then table row, and then table headers. So to get the number of columns, we need to type here head tr th, and we count this. So how to test it? Let's go to our test. I don't need this, and I don't. I need this. So I'm going to assign my grid to a variable and then use it. So let's get the number of columns. Here I put dot, choose get column count, and what we can do is to type to print this in the report. Column count. Let's play our test, and one more statement here. Play. And here in the report, we see that the number of columns is 7, which is the right value. Okay, let's implement getting the name of the column. So how to get the name of the column? Let's look at the DOM tree. And here we can see that the name of the column is contained inside div element, which is under the th tag. Okay, let's go here and put correct stuff here. Th and div. And now I'm going to write some code that will just print column names. So we are making a loop over all columns that are available, and put column name into a variable. And here we have column name and column index is I, and we are going to print this as well. Okay, running. Okay, something went wrong. What was it? Okay, we wanted to get the name of a specific column. What I forgot here is to parameterize my expression. So we need a table header and specific index. And since index is 0 based and express is 1 based, I'm just adding 1 here. Play again. Okay, so now Rapise is able to detect names of the columns. And I'm going to implement a couple of more actions here. I'm not going to implement everything. We will need getting column index from name of the column. So to do this, we need to get all the names here and then choose the name. Okay, let's test it. For example, we want to find out what is the index of column title. Column index title, and then print it. Column executing. Should be 2 if it works correctly. Yes, column name is 2. Okay, and the last thing I'm going to implement here is finding a specific cell. Let's scroll to the function that searches for a cell, and it is given 2 parameters, row and column. And here, column can be a string, name of a column. In this case, we get the index of the column using its name, or it can be a number. So, and let's add a few more expressions here. If row is an index, is a number, then we need to find the body tr. So we search for the row, and then under this row, we are searching for td in a specific column. Also, Rapise can find the cell when row is a string value. So let's type here searching for a column. Adam, we got a message in the chat that sound is not working. Can you still hear me?
Yes, I already wrote to the person. They
Okay.
didn't connect to the audio, so don't worry.
All right.
So don't worry.
Okay, then here we want to get all cells in a column with a specific number. So here is the express that gets each call plus 1 cell in a row. And after that, we filter those cells on the text which is in the row. So, and probably here we need to go to div as well in such td. I think this should work. Okay, let's test it. What we're gonna do here is to perform a click. Do click cell. Here the first parameter is a row. Let's first click on row number 2, which will be index 1, and in column 2. And we'll see if it works or not. And here we also can pass what type of click we want to do. We can pass a double click, for example. Let's play. Okay, so here we see that Rapise clicked in the second row in the title column, which is a column with a zero-based index 2, and it performed double click. This is why the part of the value here is highlighted, is selected. Okay, let's check that clicking on a column by name also works. So let's click in row 3 in column title, and let's also do double click here. Okay, what we have here is that we clicked in the row 3. Was it actually row 3? Oh, we did not, I did a mistake, not do click. It should be do click cell. Running again. Clicking on the first, and then we clicked in the row number 4, I guess. Yes, this is row number 4. So it works. The last thing that we need to look at in this implementation is how to record the click on a particular cell. So let's return to our recorder file, and here it has a get cell function that by default returns for every click, it returns coordinates 0 and 0. I'm going to paste some code here. It requires some time and skills to develop. However, it's not very complex. So here is the function, and we will quickly look what it does. Basically, what it does, this function receives an element on which we clicked as a parameter, and what it does, first it climbs to first TD to find the element which corresponds to a cell. Then it climbs to nearest parent with the tag tr. This code is executed inside the browser. And when we found cell element and row element, then we execute a couple of XPath searches. So first one is we count the number of preceding rows for preceding cells for the cell on which we clicked to find out index of the cell. Then we do query to get the name of the column when we know the column of the cell. And then we get the text written in this cell. And if this text is empty, then we will use index of the row. So given this function here, let's do recording. For example, I'm clicking here in the name column on mark. Let's look at recording activity. Please recognize that we clicked on the table grid. The action was click cell, and we clicked on a specific value in column name. So let's finish. Okay, so this is the action that was recorded. So we have our control implemented. This can be done by someone experienced on the team, and we can help you train such a person in your team who will be able to implement custom controls if needed, or we can do this ourselves. And once this is implemented, then QA team can just use this library and even do not see and do not work with JavaScript. So I'm going to create an RVL spreadsheet in my test. RVL stands for Rapise Visual Language. And I'm going to delete everything from here. And we will be working with RVL. So here is the spreadsheet. And we can just start implementing our test. And let's expand the object. And here, when we scroll down, we see here that here is our grid. And we can expand actions that can be applied to the grid. Here we need to do click cell. And here are parameters that can be passed to this section. So not a line of JavaScript required to do this. So for example, we want to click in the row 3 and in the column title. And we can specify type of the click, and we even can specify offset inside the cell. So for example, let's click with some offset from the left top corner. So now I can execute it. And repeat, clicked on the cell. I didn't see where it clicked, so let's increase offset a bit. Okay, here we see that the first word in the cell value was highlighted. So what we have? We have a library that we created from a template, then implemented some important parts for supporting such custom control as a grid. And this library is included into our test and can be supplied together with the test coverage. And so you can take the test and the library, which is inside the test, put on another computer, and then execute the test. This library is not dependent on Rapise installation. It means that if you upgrade Rapise to a newer version, this library will persist. It will not be erased. You will not need to implement it again. And we added a control, and Rapise recognizes this control as any other control it supports by default. So it is shown in the object tree with an icon. You can expand it to see what actions can be applied and what properties can be read from this object. And also this object can be used in RVL. So you see it in the drop-down for object names. You see all the actions, and you can specify parameters. And what is most important is that we have automatic recording. So I can start recording, And I can click somewhere in the cell, and Rapise recognizes this object and recognizes my action, in which column I clicked and on which value. Okay, so we have a test with the library. So let's insert. And now I can save this test into Spire test, which is a test management solution for Common Flectra. Let's go to test management part and we'll create a test case. So I'm going to create a test case. I will name it inside plugin. And in Rapise, I can save my test together with the library into Spire test. So here, let's scroll to inside plugin test case. Should be here. Inside plugin. Let's check here. Let's do refresh. Okay, I am saving. And all the files of the test and the library will be uploaded to the cloud, to Spire test. And now I'm going to create a test set that will contain my test case. I'm going to test sets list, creating a new test set inside plugin. And into my test set, I need to add my test case. Scrolling down, add, and here is my inside plugin test case. And I can close Rapise. And in my test set, I can assign it to be executed on a particular host in my environment. I will use the current host. So I'm choosing the identifier of my current host, and I'm setting scheduling date to some date in the past. In this case, it will be executed immediately, and saving. Here on this machine, I have Rapise launcher running. This is a component which is installed together with Rapise. This is the service that monitors Spire test. It performs queries to Spire test on a regular basis. So here it is configured to query data from Spire test every minute. So in a few seconds, it will discover that there is a test set that should be executed. And then Rapise Launcher will download all the tests, all the files into a temporary folder. If it will be some other host, all files will be downloaded on the other host, and then the test will be executed. So we should see here the test set at the moment. Okay, it's here. So now Rapise Launcher downloads all the necessary files together with the library that we just created. And once, okay, we see here that execution has been started and our clicks were performed on the application. We can now go to Pirate test back to test run section, and here is the report for our test. We see that all clicks were performed successfully, and here is the report, what clicks we performed and with which parameters.
So, in summary, most applications unfortunately will use custom controls when you're extending Dynamics 365 for operations. Those custom controls may comprise grids, lists, tree views, and charts. And many applications will require those custom controls to perform business operations. Rapise can make your life much easier because it lets you, as the programmer, implement a framework extension so that your business user can then just simply perform recording of high-level operations, clicking on things, using the application, and makes it much easier to do testing. The other great thing is that the extension library that you've created becomes part of your test framework. It's stored with your test cases and code managed within SpyroTest or your source code management solution and is fully integrated with Rapise. So for your testers, the custom extensions that you've written are as part of the Rapise as any of the built-in libraries that we've written. So they don't have to learn a whole separate technology or a whole separate design pattern. Thanks for watching. Please subscribe to our YouTube channel for more videos on software testing. Have a great day.